13.75 billion years ago, the universe began. Why, we don't know. 380,000 years after the Big Bang, it's a very precise number, you might say. How do you know that? Well, before that time, the universe was so hot that atoms couldn't form, so you had a soup of electrically charged particles. It was just too hot for electrons to go into orbit around nuclei, so the universe was opaque to light. It was like one big glowing star. Imagine if I told you that our universe has been around forever, even before the Big Bang. It might sound pretty wild, right? Well, hold on to your hats because renowned physicist Brian Cox is on board with this mind-bending idea. It's interesting, this idea that the Big Bang created the universe. That's what Einstein's theory says. That's textbook cosmology if you like. But the current textbook picture is there was a phase in the universe's life before the Big Bang. If you define the Big Bang as the hot dense phase from which the universe appeared, sort of burst forth 13.8 billion years ago, that phase is called inflation. So what we think happened is that before that, the universe was accelerating exponentially fast. It means it was doubling and doubling and doubling in size, and the numbers are ridiculous. We think that if you started with a universe that was smaller than a single atom, then it would be bigger by a long way than the whole observable universe, 350 billion galaxies in it, in less than a millionths of a second. So very rapid, exponentially fast expansion. And when that stopped, all the energy that was driving that expansion got dumped into space. It heated it up, it produced the particles of matter out of which we're made and all the things that we see out there in the sky. And that's what we see as the Big Bang. So that sounds like a fluke, but that's standard cosmology at the moment. The big question then is, well, what started the inflation? What stops the inflation? How long did the inflation go on for? And the answer to that is, we're not sure. We don't know. There are theories now that suggest, as I mentioned, that there may be more than one universe and potentially an infinite number. It's a mind-boggling idea, isn't it? And I should say one extra thing. If that's true, then some of those theories say that what we call the constants of nature, so things like the strength of gravity, the speed of light, the masses of the particles, can vary from universe to universe. And then you ask the question, well, why is our universe so perfect for life? Why do stars make carbon and oxygen the elements that you need for life? Why is everything so beautifully balanced so that living things can exist? The answer in these cases is because, well, every universe exists. Every possible combination of the laws of nature exists in different universes. So the reason we have to see a universe that allows us to exist is obvious. We could ask the question, well, how likely is that? Well, the answer, if there are an infinite number of them, is it's inevitable because there's every possible kind of universe. And I stress that this is very speculative stuff. But the first thing I said about inflation, the idea that there was this exponentially fast expansion before the Big Bang, if you want to use that language, that's not speculative. That's mainstream cosmology. This idea that may lead to multiple universes is more speculative, but it's still scientifically valid, and there are people who do research into that. And again, this is an active area of research. It all stems from a theory put forward by none other than Sir Roger Penrose, who suggests that our universe is just one in a whole cosmic lineup. Penrose's theory shakes up our understanding of time and space by proposing that there might have been universes before ours, all part of an endless cycle of creation and destruction. Picture it, countless universes popping into existence over unimaginable stretches of time. It's not about infinity with no beginning or end, but rather a series of beginnings and endings. So what does this mean for our grasp of reality? Could it be that time itself doesn't have a beginning or end? It's a mind-bending notion, but one that's worth exploring. So let's dive in and see where this rabbit hole leads. In scientific circles, Sir Roger Penrose is esteemed as a brilliant mind with a reputation in the UK comparable to that of the late astrophysics luminary Stephen Hawking. Penrose holds a Nobel Prize and was knighted by the British Queen for his scientific achievements. One of his most controversial theories is conformal cyclic cosmology, which suggests that our universe may have originated from a previous one. This theory challenges conventional notions of time and space. Recently, the James Webb Telescope provided new support for CCC with discoveries that contradict traditional cosmology. Let's delve into the surprises revealed by the James Webb Telescope and what they imply for Roger Penrose's CCC cosmology. Alongside the 16 galaxies that existed so early in the universe that they must precede the Big Bang, 6 black holes also emerged, exhibiting similar characteristics. Just a few 100 million years post-Big Bang, these colossal entities already surpassed 1 billion solar masses. Then a scientific revelation shattered existing explanations. The discovery challenges previous notions about the Big Bang's timeline. While not as ancient as other findings by James Webb, this galaxy, nearly identical to the Milky Way, raises questions about established theories. Although galactic resemblances are not uncommon, it took billions of years for our Milky Way to evolve into a fully formed spiral galaxy. This newfound galaxy existed approximately 2 billion years post-Big Bang. Assuming galaxies like this one require billions of years to develop, their age stretches beyond the Big Bang. This presents a unique advantage compared to James Webb's other discoveries because of its proximity. Analyzing the light of this galaxy is somewhat easier compared to the even older galaxies spotted by Webb. The data regarding the number of stars, their compositions, and the formations within this galaxy are more reliable. They indicate that this galaxy exhibited a level of maturity similar to our Milky Way only billions of years after the Big Bang. Have you ever pondered the idea that our Milky Way also existed in some form during the early universe? It could have been a small irregular globular cluster at that time, or perhaps our Milky Way is much older than previously believed and was already traversing space as a fully formed galaxy some 13 billion years ago. With an estimated stellar mass of approximately 3.9 billion solar masses, it's considerably larger than expected for galaxies of that age, although still relatively small compared to the Milky Way. However, the primary question regarding the evolution of galaxies in the early universe revolves less around mass and more around shape. The shapes of galaxies are believed to evolve through intricate merging and growth processes spanning billions of years. How does this recent discovery lend support to Roger Penrose's conformal cyclic cosmology? According to CCC, the universe didn't begin with a traditional Big Bang concept but emerged from a previous universe, with all information about matter, stars, and galaxies already existing. Despite this, each new universe in CCC still starts with an event akin to a Big Bang. Previous cosmologies struggle to explain what came before the Big Bang. Classical physicists claimed nothing happened, while quantum physics proposed a quantum tapestry of equilibrium. However, the origin of this quantum fluctuation remained unexplained until Penrose's idea offered some insights. The CCC is highly complex, so here's a simplified overview. Picture a universe much like ours, where massive black holes consume all matter. Eventually, as the last star and grain of dust vanish into these behemoths, physical forces halt. This initiates a chain reaction akin to the universe's demise. For a brief period beyond our time frame, the universe reaches complete equilibrium, devoid of measurable forces or matter. Only the black holes may persist or evaporate in this transition from death to renewal. Eventually, a new universe emerges from what we might call a spark of life, or more scientifically, a law of cyclicity. This kickstarts the creation process anew. Penrose's theory suggests that the universe's properties at its end closely resemble those at the beginning of a new era. He developed the CCC concept while exploring the core aspects of general relativity and quantum mechanics. To this day, the two disciplines remain considered incompatible. Penrose sought both points of contact and contradictions between them. In his exploration, he observed the significance of singularities and the characteristics of the cosmic microwave background. He noted that the thermodynamic time direction of the universe, as dictated